Mainframe, a term often heard when movie protagonists talk of a platform where tons of data, especially sensitive data, is stored and secured. It creates an impression of big machines whirring 24 hours a day, 7 days a week, all year round, processing information for government, business, manufacturing, and major industry. But how did mainframe come into being? How did it evolve in history? Who were the pioneers, and what companies were and are still involved? Prior to the mainframes that we have today, the quest for advancement in data and information processing, starting with the building of ENIAC, Electronic Numerical Integrator and Calculator, in 1942, was then followed by Mark I, BINIAC, Whirlwind, and UNIVAC, Universal Automatic Computer, delivered to the US Census Bureau in 1951 and considered to be the first mass-produced computer. Its central complex was about the size of a one-car garage, 14 feet by 8 feet by 8.5 feet high. Because its vacuum tubes generated an enormous amount of heat, it was continuously cooled by water and air conditioning systems. Shortly after UNIVAC, IBM entered the picture in 1952, introducing their first generation of mainframe, the IBM 701. The first in its pioneering line of IBM 700 series computers. Devised in one of its laboratories, Columbia University considered it to be one of the first large-scale commercially available computer systems for solving complex scientific, engineering, and business problems. Sometimes referred to as defense calculator, it increased the number of addition and subtraction operations from 11,000 to 16,000 per second. In 1959, IBM upped the ante by launching its second generation of computers with the introduction of IBM 1401, an all-transistor data processing system that placed the features found in electronic data processing systems at the disposal of smaller businesses. Not long after, in 1964, IBM changed the landscape with its risky and bold move of implementing its third generation of computers, the System 360. It was a product of IBM's $5 billion investment to adopt a new architecture specifically designed both for data processing and to be compatible across a wide range of performance levels. As they say, the rest is history. With the enhancement of virtual storage in the System 370 upgrade in the 1970s, the Year 2K compliant OS 390 in the 1990s, up to the Z series that we know today. Parallel to advancing the features of mainframe in the 1950s was the desire to come up with a program language that is common or compatible across a significant group of manufacturers. Joint effort by the computing industry, major universities, and the US government through the Conference on Data System Languages, CODASIL, gave rise to COBOL in 1959. COBOL was designed within a 6-month period, designed for developing business applications that are typically file-orientated, and it is not designed for writing system programs nor for handling scientific applications. Although COBOL is simple, portable, and maintainable, it is very wordy in nature and has a highly rigid format, requiring major COBOL programs to typically contain more than 1 million lines of code. Even though huge investment was made in building these 1 million lines of COBOL applications, they continue to be long-lived and are still the backbone of the IT infrastructure of many financial institutions today. According to a report from the Gartner Group, it was estimated in 1997 that there were about 300 billion lines of computer code in use across the world. Of that, they estimated that about 80%, or 240 billion lines, were in COBOL, and 20%, or 16 billion lines, were written in all the other computer languages combined. In spite of its popularity and wide base of users, the advent of newer technologies led many to say and predict the unplugging, sunset, or demise of mainframe, relegating the so-called Jurassic platform into oblivion. Ironically, in 2004, IBM celebrated the 40th birthday of mainframe, launching the following year the result of over $1 billion in R&D investment, the Z9, the latest generation of the Z series platform. In 2009, the Linux on System Z was introduced, enabling a truly open operating environment, while after the 50th anniversary celebration in 2004, it's the launch of the Z13 enterprise server, IBM's answer to the ever-growing area of mobile, data analytics, and cloud computing. What's the reason for the continued stay? Mainframe has kept its traditional advantages over the non-mainframe platforms: reliability, availability, scalability, and security. At present, Micro Focus estimates that in big business, COBOL still accounts for 70 to 75% of all computer transactions and business data processing. But there's C++, Java, even Node. Why not use them? Well, COBOL can do many things that other program languages simply cannot do easily or cannot do at all. These include accessing indexed sequential files, producing formatted numeric output, running in a pseudo-conversational interactive environment, accessing hierarchical and network databases, and producing very huge files. Add to this the fact that other languages have no concept of records, which is vital for business applications. This is what separates COBOL from the rest. C++, Java, Visual Basic, these languages were not developed to compete or replace COBOL. It's just that producing large files, producing formatted reports, or providing an online interface for hundreds of concurrent in-house users for a business application is the turf of COBOL. Hence, that's why there's a B in COBOL. It stands for business. There are, however, several companies, like Micro Focus or Sun, that are offering migration technology that makes it possible to emulate the mainframe environment, taking the applications off the mainframe but performing the migration without having to do a complete rewrite, thus avoiding enormous manpower cost. Just imagine the estimated 210 billion lines of COBOL in production today and still growing. Add to the emergence of the above-mentioned alternatives for the following concerns about the viability of mainframe: cost of mainframe hardware, declining availability of COBOL skills, integration of price. It should be observed that for sub 1000 MIPS mainframe platforms, the traditional advantages of mainframe over the non-mainframe platform are eroding very quickly. In such cases, the very high cost of mainframe hardware is difficult to justify compared to the 10 times less expensive Intel or AMD combination. With this, it is perceived that the sub 500 MIPS mainframes will be a thing of the past in the next 5 years. On the other hand, the same cannot be said for very large mainframes, 4000 MIPS or more. CIOs of companies using these systems still think that benefits outweigh the cost in their current situation, although strategies that would balance IT expenses, risk, and innovation are always being addressed. With the skills crisis is the claim that COBOL will come to a halt due to the decrease in skills base. It's believed, however, that there will be no acute shortage in the short term, as the fall in the number of COBOL developers will be offset by a comparable reduction in the amount of COBOL development that will take place. Nevertheless, employers need to address the issue in the long run, since starting last year up to 2020, the older generation of COBOL developers will start leaving the workforce. Although there is still a consensus that integrating mainframe-based applications with distributed applications is too costly and complex, IBM is introducing new and better technologies that would enable independent software vendors to easily port their classic or Java-based applications to the mainframe. Taking this into account, it's still believed that although companies with sub 500 or sub 1000 MIPS-based mainframes will migrate to non-mainframe platforms, those with larger mainframes will still grow in the coming years. Besides, the recent release of Z13 only attests to IBM's commitment to supporting its existing clients, hence seeing a long-term future for the mainframe platform. The future is very much in the mind of CLPS, a global IT service and solutions company founded in 2005 with the initial goal of supplying qualified IT resources to financial institutions that would like to tap the potentials of new university graduates in China. There were no well-suited mainframe training programs in universities at that time. CLPS created a platform that used actual mainframe programming environments to facilitate learning. Trainees were able to log in using actual TSO IDs, compiling their programs just as if they were doing it in the development environment of a bank's legacy system. We started with just 12 new graduates. Over the past 10 years, the company has now delivered over 5,000 technology talents to global banks and financial institutions, partnering with universities and colleges through its internship program for the continuous supply of talents to be trained and deployed. CLPS didn't stop there. Understanding the need to equip students with not just the programming basics, but with applicable, practical, and in-demand skills that banks and financial institutions are looking for. CLPS independently designed a dedicated platform which consists of modular, real-world banking systems, the CLPS Virtual Bank, therefore creating a technology environment for training financial IT professionals. The CLPS Virtual Bank training platform is not a theoretical course, it's a real-world system. Our Office ATM is plugged into it. It combines mainframe, online, mobile, back, middle, and front office technologies, enabling a complete training needs development platform for banking IT talent in technology, project, and business analysis, and delivering individuals and teams that have real experience at analyzing business requirements and implementing technology solutions. A complete banking technology training platform that addresses the skills gap that banks and financial organizations currently face. Most importantly, the virtual bank can be deployed in clients' data centers or inside CLPS's own data centers. This means you could build the whole system with full control of the license model, or have the safety to experiment with the system with no risk to your own equipment or network, simply paying a per-user fee using a SaaS model. There's nothing to worry about the lack of direction for mainframe. The need for mainframe and mainframe talent is still there. The demand continues to exist, the ideal training platform is available, and the raw talents are out there waiting to be honed and put into this ever-challenging world of financial technology.